The API platform setup that we're using, aka the default that's provided via Docker Compose, runs a Postgres database. And in the two previous Symfony 4 API implementations, we were using MySQL. So as such, our cleanUpDatabase method expects a MySQL database. And also all our credentials are incorrect. You can find all your credentials in the docker-compose.yaml file. Just as a quick heads up, in the previous video we removed the before scenario tag from the original cleanUpDatabase method, and by remove we simply added a space between the at and the before scenario. We saw that if we didn't do this then our tests would fail. Now whenever you're switching projects between the original Symfony projects and the API platform project and the forthcoming Koa.js project, you're going to need to make sure that you're using the appropriately tagged method. And I know this is a manual step, but then switching between the projects isn't ever going to be really straightforward. That's just a side effect of the setup, unfortunately. So I'm going to use different credentials than those provided by default in the Docker Compose YAML file. I'm going to go with the DB user, DB password. It's very similar to what we had before. You don't need to change this, but whatever values you use, make sure that you update your applications.env file and your FeatureContext file accordingly. In the .env file, the interesting line is database_URL, and you may also want to update the env.dist accordingly as well. That's really your call, I'm not going to do so. There's a couple of important changes not to miss inside our cleanup Postgres database function. The first one is to make sure that you're using the correct port, which is 5432, and the second is to use PG_SQL at the start of your DSN, and you also don't need the char set, so you can get rid of that. But there is an extra bigger step that we need to take, and that's to restart the ID sequence back to 1, which we're going to need to do independently of truncating our album table. Now this is something that you don't need to do with MySQL, and if you don't do it for Postgres, then the generated IDs after the first test run are going to be wrong. So it's still going to truncate your table, but say we had 3 albums as part of our fixtures, then the first time that we run our tests, the IDs would be 1, 2 and 3. And then it would truncate the table, but the next ID would be 4 because we didn't restart the sequence. So when the tests run again, the ID would be 4, 5 and 6, and of course we're looking for specific IDs, and that means our tests would fail. So all that remains at this point is to remove the space between the at and the before scenario on our tag, and we should be good to start testing post requests. As I've changed some environment variables, I'm going to need to restart the environment, which in this case is as simple as running make dev. As a quick recap, that's going to shut the environment down and then bring it back up. Now it seems that because I've already brought the environment up once, the database has a different password than what it is that I've now changed to, and the quickest way to fix this is to simply delete the volume. In order to do this, I need to shut the environment down, so I'm going to run the make down command, and then I need to know the name of the volume that I want to delete. Now this is kept in the Docker Compose YAML file. As we can see here, this is a named volume, and the name is db-data. Now the volume name itself won't be exactly db-data, but this is a good starting point that we can use after we've run a docker volume ls, in other words a docker volume list. From there we can see the real name of our volume, which we're just going to take a copy of and then use that in the command docker volume rm for remove, and then paste in that volume name. I'm now going to run make dev again to bring up our environment, and whilst doing so we can quickly take a look at the Docker Compose YAML file, and if you'd prefer you could use a bind mount instead of a named volume. Just comment out the named volume and uncomment the bind mount. I actually prefer bind mounts, I think they're a little easier to work with, but the Docker best practice is definitely moving towards named volumes. As we've now deleted that volume, we'll find that when we bring up our environment once more, the Postgres container will be created with the expected credentials. But things still aren't quite right just yet, because our cleanup script is going to try and delete an album table, and of course that album table doesn't exist yet because we don't have an entity around our album. So as a quick recap, our Behat setup relies primarily on us being able to send in a post request, and because our Behat project needed to be independent of our different API implementations, we need to be able to post data into our API in order to satisfy the background steps of our Behat feature. This then sets up our database, allowing the other get, put, delete, etc. tests to run properly. So with this in mind, we need to start with the post test. I can tag this test with our usual tag of T, but at this stage we should expect our test to fail, as we don't have the concept of an album inside our API platform project just yet. In other words, we don't have an album entity. Not that any of this really matters, because as we've already seen, the background step expects to be able to drop a table called album, and if it can't do that, it won't even get to the point where it tries to run any of our individual scenarios. Now, somewhat unusually, the greeting entity that comes with the API source entity folder by default uses public class properties. And from the documentation, this is stated as just being for simplicity. I'm going to go with the more traditional private class properties, which will mean we'll need getters and setters. Now, whatever approach you prefer, I would generally recommend keeping the ID property private, and using a getter would be a good shout in that circumstance. There's a whole can of worms around that subject, and it's a can of worms that I don't want to open in this video. Now, a starting point for our album entity could be a copy and paste from our previous project. The only absolutely essential addition over what we had from previously would be the inclusion of the API resource annotation on the class itself. You don't need to copy over the album repository, and this is still going to work just fine. Now, there is an alternative way to work with your data models in an API platform project, and we're going to cover this alternative approach in the next video, where we'll generate an entity using the API platform schema generator. You can take this approach, or feel free to skip ahead to the next video at this point, but whichever approach you take, we do need to make Doctrine aware of our changes, and as such update our database's schema. Now, you may want to take this as an opportunity to delete the default greeting entity also. If you do so, then when you run the Doctrine schema update, you're not going to get a greeting table created. You don't have to, but it's a worthwhile step to take in my opinion. Now, I'm going to force through this change, but in a real project, I would strongly recommend using Doctrine migrations for this process. And as quickly as that, we have 5 new routes for working with albums. This is to get one album, get a collection of albums, post in a new album, put or replace an existing album, and also delete an existing album. Now at this stage our tests still fail, and the reason for this is that our routes are pluralized, so that's albums, not album, as we want. Now in order to change this, we need to define our own operations, and we're going to get onto that, but as I've just said, the first thing that we're going to do is look at the alternative way to generate entities through using the API platform schema generator, and we'll get onto that in the very next video.